This lesson covers an introduction to systems of equations and what the solution to a system of equation is from a visual standpoint. So what is a system of equations? Well, a system of equations is a group of equations that share the same variables. The set of equations is grouped together by a bracket. So we have three examples here of what a system of equations may look like. First example here, we have the two equations y equals 3x plus 2 and y equals 5x minus 9 grouped together by that bracket to indicate that they are a system of equations. Okay. The next example we have here, instead of just two equations, we have three equations. What you'll also notice is that there's 1, 2, 3 different variables in that system of equations. Lastly here, we have another system. Here we only have two equations in this system of equations. And again, what you'll notice is that we only have two variables. More often than not, what you'll notice is that the number of variables in an equation equals the number of equations in the system of equations. This must be the case if a system of equations is solvable. We're going to restrict ourselves for this introduction to systems of equations where we're dealing with two linear equations. A linear equation having two variables, generic x and y variables, and two equations. So we would say that this is a system of equations in two of variables and two equations. Now, important thing to note in regards to a system of equations is that the x in each equation is the same, the y in each equation is the same, and in the case of this middle example, the z in each equation is the same. So a system of equations is a collection of equations where the variables represent the same things in each equation. So the goal now is to take a look at some linear systems of linear equations in two variables and to determine what the solutions or the solution of a system of equations is. So to do that, we're going to take a look at an example of graphing. So what is the solution? The solution to a system of equations is a coordinate point that satisfies each equation in the system of equations. Okay? So key thing here, it's a coordinate point, meaning it has an x and y value, and it satisfies each equation in the system of equations. It doesn't just satisfy one, it satisfies both. One way to visualize the solution of a system of equations is by graphing both equations on the same coordinate plane. So let's do that. In this first example, we have a system of two linear equations. We have y equals 5/2 x plus 4, and we have y equals negative 1/2 x minus 2. So these are the two that we're going to be dealing with, and we want to graph them. So this first equation of y equals 5/2 x plus 4, to graph this, I'm going to start at the y-intercept of 4. Y-intercept of 4 is right here, so I'm going to put a point here. Okay. And then from that point, I'm going to use my slope of 5/2. So that's up 1, 2, 3, 4, 5, and over 2 to get my other point. Now I could also go down 5 and to the left 2 to continue the pattern in the other direction. And now I have several points that I can connect the dots and get the graph of my equation. So there we go. There is the graph of the equation y equals 5/2 x plus 4. Now the other equation that we want to graph is right here, the y equals negative 1/2 x minus 2. So again, we follow the same pattern. We're going to start with the y-intercept. Our y-intercept here is negative 2. And we have a slope of negative 1/2. That would be down 1 and to the right 2, negative slope. Now again, I could go the opposite way. I could go up 1 and to the left 2. Okay, and again I have a sequence of points, or a series of points that line up in a line, and now I can draw a line through those points. And this right here is now the equation of the line y equals negative 1/2 x minus 2. So I've got both equations graphed on the same coordinate plane. Excuse me. You can see though that there's a location at which both intersect each other. That location is right here. So we said earlier that the solution to a system of equations is the coordinate point that satisfies both equations. Well, the graph of an equation represents the collection of points that work in the equation. So what is the only coordinate point that will work in both equations? It's the point at which these two lines intersect each other. That point from this graph looks like it's the point -2, -1. So we would say that the solution to the system of equations is the point -2, -1. This is the xy coordinate point that will work in both equations. So if I were to plug in -2 for the x's and -1 for the y's, it would work and give consistent solutions to both equations. So again, the solution to a system of equations is the point at which both equations are satisfied together. From a visual standpoint on a coordinate plane, that is the point at which the two lines intersect each other. Let's go ahead and take a look at another example of this. The graphing of this, the concept is the same, but the graphing of this is going to be a little bit different because our equations are in standard form rather than slope-intercept form. There's a couple ways we can go about this. Just to give a little variety, I want to go about it in the way of finding the x and y intercepts. So, to find the x and y intercepts, let's start with our first equation, the 3x plus 4y is equal to 8. How do we find the x-intercept of an equation? We plug in 0 for y. So if I plug in 0 for y right here, that term goes away, and I have 3x equals 8. Solving for x gives me x is equal to 8/3. So there's my x-intercept. Now what about my y-intercept? Well, the y-intercept comes when you plug 0 in for x, which makes this term go away, so you end up with 4y is equal to 8. Solving for y here by dividing by 4 produces y equals 2. So what I now have here is the x and y coordinates of this equation. So I can take those and plot them and construct a line through those points. So a y coordinate of 2 is this point here, and an x coordinate of 8/3. 8/3 is 2 2/3. It's just shy of 3, so that's about right here. Okay, and now I have those 2 points that I can connect the dots with. So let's go ahead and do that. Let's connect those points. And now we have the equation of our line, of our graph. And this right here was the graph of the equation 3x plus 4y is equal to 8. Well, we have this other graph that we need to put on the coordinate plane now. It's the equation x minus 4y is equal to 8. So let's go ahead and do that. How do we find the x-intercept again? By plugging 0 in for y. If I plug 0 in for y here, that term goes away because 4 times 0 is 0. And I'm left with x equals 8. So x equals 8 is the x-intercept. Now I need to find the y-intercept. To find the y-intercept, we plug 0 in for x. Making that term go away, I'm left with negative 4y is equal to 8. Solving for y here by dividing by negative 4 produces y is equal to negative 2. So I now have my x and y coordinate. My x coordinate is 8. That's all the way out here. And my y coordinate is negative 2. Is negative 2. Okay. Now that I have those 2 points, I can connect these to get the graph of my equation. So we now have the graph of the equation x minus 4y is equal to 8, also graphed on our coordinate plane. So the solution again to a system of equations is the point at which the two graphs intersect each other. Now, because we were dealing with some awkward numbers like the 8/3, and because we're not exact in drawing, the point is going to be a little bit off. These problems are set up to have whole number solutions, so we see that it intersects really close to that point right there. Okay. And in fact, if we were a little bit more careful and counted a little bit better, we would find that that intersection point truly is at that point right there. What is the coordinates of that point? Well, it looks like it's 1, 2, 3, 4 in the x direction and negative 1 in the y direction. So the solution to this system of equations is the point 4, negative 1. So 4, negative 1 is the solution to this system of equations. It is the one xy coordinate point that if I were to plug into either of these equations, it would work. We do want to take a look at one last example. It's a special case, and you'll see why it's a special case fairly quickly. So we've got another system of equations here, two equations, two unknowns. We have y equals 2x plus 2 and y equals 2x minus 3. They're in slope-intercept form, so we can graph them fairly quickly. So let's go ahead and do that. We have y equals 2x plus 2. That is a x-coordinate, or a y-intercept, sorry, of 2. So I'm going to draw a point here at 2. And then I have a slope of 2. Slope is rise over run, so we can think of it as 2 over 1. So up 2 over 1. And I can do that a couple more times just to get a few more points to connect. Now we can connect these points and get the graph of our line. So this right here is the graph of the equation y equals 2x plus 2. Now we have this other equation, the y equals 2x minus 3. We need to graph that one. So it has a y-intercept of negative 3. So I'm going to go ahead and go down here to negative 3 and make a point. And we have a slope again of 2. So that's up 2 over 1. Up 2 over 1. Got several points now that I can connect the dot with. So let's line that up. And we'll draw the equation of that line. Now quickly you're going to notice something. If we're supposed to find the solution to this system of equations, we need to locate the point at which these two equations intersect each other. The question is, will they ever intersect each other? And the answer to that, as you might guess, is no. In fact, we wouldn't have even had to graph these to know that that was the case, because if you take a look at this scenario, what is the slope of both equations? The slope of both equations is 2. What does that mean? Well, that means that they are parallel to each other. And on a plane, parallel lines will never intersect each other. So in this case, because we know that these will never intersect each other, we can say that this system of equations has no solutions. So there are special cases in which a solution is not able to be found for the situation that we're dealing with. So again, system of equations is a grouping of equations with similar variables, and the solution from a visual standpoint is the location on a graph in which the two lines or the two graphs intersect each other, and the coordinate point, the xy coordinate point, is the solution to the system of linear equations.